So I'll start with the need for embracing data. And most of you already understand this need, but I want to put a different spin to it, especially because you are taking this class as part of the MBA program, where there is a managerial piece that is critically involved in the puzzle. And when you ask yourself the question, when somebody manages a company, when somebody manages an operation, when somebody manages a group of people under that person, um, when somebody manages a warehouse, when you use the term manage, exactly what are you doing? Are you doing the same thing over and over again, versus are you trying to improve on something? Are you trying to squeeze the maximum amount of efficiency that you can from the people from the company? Are you trying to increase the company's profit margin? Are you trying to reduce those costs? So there is an aura of improvement in every section in which you are trying to manage. And therein lies the idea of what Peter Drucker has said, and that has become folklore today in the analytics world, that you cannot manage what you cannot measure. So unless I know what my current profit margin is, how do I know the extent to which I want to improve that? Unless I know what the current efficiency level of my employees are, how do I know whether I can make that even better? Unless I know the amount of time it takes for a patient to be served at a hospital premises, how do I know if I can improve on that time that the patient spends in the hospital? Okay, so the satisfaction and all of those things, that is all around the idea of improvement. But the underlying thought here is you cannot manage what you cannot measure. And when we talk about manage, in essence, you're talking about improving something that is already in place. That's what management is about. In some form or the other, you're always trying to improve on a process. And that process can be a financial process, a planning process, working with your customers, working with your internal people, working with human resources. But at the end of the day, it is about improving that process. And so that's where the idea of measuring comes in. And this is why the need for embracing data is more important than ever. So why quants? And we have talked about this in bits and pieces, but I wanted to put some structure around the discussion. So first and foremost, ours is a data-driven world. And we all know that. And I'm going to provide a few anecdotal evidence that will hopefully help you understand that, oh my God, we are living within that world. Okay, we are a part of it. There is no way to live outside of a world that is not data-driven. Okay, so data-driven decision making, seriously, you bet. Government elections. This is the year, right? 2020 is the year of elections. And so when you think about elections from an analytical perspective, ask yourself, I mean, when a certain party becomes the winner, what is the underlying assumption based off of when those wins happen? Okay, so number of ballots won, number of votes won, um, uh, by states, by um, uh, Congress, and so on and so forth. So, everything is built on data. Whether a certain um, forerunner has a chance to eventually win a certain state or not, when you go through any of the news agencies, be it Fox News, be it CNN, or something else, you'll see that they'll be constantly probing you with numbers. In terms of what the numbers look like today, what the exit polls looked like yesterday, how they want to look tomorrow. So it is extremely numbers driven, and there are also forecasts that happen around the decision-making process that allows you to get through that election process. So I have at least 2 to 3 people here in this class who have served in the army. Okay, so a very simple setup. Okay, the US success failure in the Middle East. And there are multiple ways of looking into it. It's depending on the lens through which you look into success or you measure success. So if the lens is how many people have been placed in that region in the last 10 years, and how many deaths have we had, um, based off of the number of people that we have been able to place there. Okay, so lower the number of deaths, there is a certain threshold around which we'll say that, okay, we will call ourselves successful, even though every single life is important internally. And when you manage that kind of a data, there is always a threshold around which you manage success versus failure. For those of you who have been involved in putting a tab on the war against, let's say, if not Taliban, but ISIS or any other terrorist agency in those areas, a lot of that war has been fought via drones. And that actually ensures that the men and women working in the US Army kind of stay away from harm's way. But it also requires that a tremendous amount of intelligence is utilized to ensure that the drones actually hit the target that they are supposed to hit. Okay, and so therefore, oftentimes the success or failure is defined by the success or failure of the number of hits versus number of misses by the drones. And believe it or not, for those of you who have heard of this term RFID, or radio frequency identification, it's a widely used tool in the industry today. But the beginnings of RFID are etched in designing success or failure of drones in the US Army. Okay, so at the end of the day, it's always numbers driven in terms of making those decisions. We live in the world of COVID-19, okay? So it is impossible to not bring that in the discussion. And for those of you who are following that promise of a vaccine, you know that AstraZeneca is probably a little bit ahead of many of the other companies in the process. They've already been through their stage 3 and currently going through a stage 4. They have also joined hands with a couple of startup pharmaceutical companies in India, and they're hoping to get a vaccine out close to the end of this year. So when you talk about release of a vaccine from an analytical standpoint, the first question is, what is the reach and what is the timing of the release? Okay, so the timing of the release again has to do with the overall product development cycle for the product, since it's R&D to inception to testing to eventually release and dissemination. And so when you look into the competitors' numbers, the expectation is the percent or the likelihood that you will beat those competitors' numbers. And all of that is built into the business plan that allows AstraZeneca to think, yes, we'll go on with this process, because there is a tremendous amount of investment in the process in the first place anyways. Okay, so their release of a new vaccine for COVID-19 is as much etched in analytics as any other decision that we come across. Seventh generation. I talk about seventh generation primarily because today it's a household name. If you guys are into sustainable living in some form, then you know that a lot of laundry detergents and dishwashing detergents are made by seventh generation, and they are expected to be made off of less harmful chemicals that don't ooze from the outlet of a machine into the soil and erodes the soil or poisons the soil. And so the reason why I'm talking about this specific example is seventh generation had a very interesting story when they first tried to get into the Walmart market. Okay, because Walmart, if you 15 years back, if you walk into Walmart, into specifically the detergent section, all you would see is different forms of Tide, and there would be nothing else. And Walmart was a little late into entering the sustainable environment and the revolution, primarily because initially those products were much costlier, and that didn't chime with Walmart's tagline, which is everyday low prices. And so therefore, seventh generation had to be extremely careful about trying to find shelf space and compete with the likes of Tides. And for those of you who have a background in marketing, probably know this, shelf space or understanding shelf spacing in itself is a science. Where the shelf is located, what is the height of that shelf, what is an adequate optimum eye level, how does the human eye move looking for a product, how would the product be placed, at what angle should the product be placed on the shelf. So all of those are coming from a tremendous amount of market research that is extremely data driven. And then at the end of the day, you would also want to differentiate between doing something versus not doing something. And that is what seventh generation did. They went into a certain locality of Walmart and designed their shelves for their products in a certain way. And in another locality, they designed it differently. And then over a period of time, they looked into how sales numbers changed from one locality to another. And so at the end of the day, again, it becomes a data-driven approach to making the decision that putting a certain product on a shelf in a certain way at a certain level actually works, because now you can probably say with a certain level of confidence that in a certain locality, because of putting the product at a certain shelf level, you found X amount of increase in sales for that product, everything else remaining the same. So that is how intrinsically data is related to decision making in our everyday lives. Okay, how do I create an investment portfolio? And I'm sure all of you already have or in the process of having an investment portfolio. For those of you who are coming from the finance insurance side, this is of course a no-gamer for you. But for the rest of you, a typical investment portfolio typically consists of a mix of certain aggressive components and certain conservative components. Okay, so the aggressive components are the stocks that you invest in, and those prices go up and down depending on the market. Certain conservative ones are the ETFs, or the mutual funds, and where there is an aggregation of stocks, and therefore they're already building risk into that aggregation. And then you have extremely conservative money markets like bonds and stuff, even though the bond market right now doesn't look really the best. So the idea is, when I create my investment portfolio, what makes me take that decision? There are a number of factors. Okay, so one of the factors, of course, is how old I am, where I am in my career track. Okay, how risky I am is one question, which is what the market will decide for you. So as one of you was talking about the insurance side, when you buy insurance, a person's insurance rates differ based off of whether you are, over 21, below 21, married, unmarried, because they have something called a responsibility index. And the expectation is that as you grow older, you are expected to grow wiser. Okay, so, and with wisdom, you are of a less risk to get the certain quote, and therefore your quote values change based off of that. And so investment portfolio is no different. At your initial stage, you would typically want your investment portfolio to be aggressive, and then at what point in your career do you want to have that balance, and eventually at the end of your career, close to retirement, where you want to be more conservative. So all of that is based and driven by numbers. Why should I invest in Apple Incorporated stocks? Okay, and so Apple stocks, I think about 5 years back, they started the split stocks. And even then, they were selling at a crazy number. It's a pretty high number for a single value of a stock. And so when you eventually make that decision, and this is what I am expecting that each one of you get out of a class like MBA 612. Oftentimes, the decision that we make is based off of somebody else's expertise. Okay, so XYZ has said that invest in it, and because they're investment bankers, they're thinking that this is a good stock to invest. Or maybe my dad or my mom or my uncle told me that it's a good stock to invest, and so I'll invest. I mean, that's not a bad route, but what is the point of education, right? So at the end of the day, you need to ask yourself, can I myself, based off of whatever little I know about analytics, make an educated decision by looking at a certain stock, see how the stock has fared over time, try and forecast where the stock is headed, try and connect that and map it with my level of risk that I'm willing to take, and then make the decision, should I invest in the stock or not? Okay, so when you talk yourself through this process, now you have really made a decision that is data driven. Okay, and that is the world we live in. And something as mundane as, why should I pursue the degree that I'm pursuing? Okay, and I have had this situation in the past where I have had students tell me, I don't know why I'm in this degree. And none of you should be in that boat. That should have been a constrained decision where you have looked into all the odds and made the decision that this is the best option for you, be it from a career growth perspective. And when you say career growth, you're putting that eventually in numbers. Okay, what can an MBA degree do for you? How can it actually catapult yourself in terms of your growth, not just in your position and reach and respect, but also in terms of your salary? Where do you want to see yourself in the next 5 years, 10 years? And how does this MBA help you? So I'm sure you have all done that level of judgment before you enrolled in the program. And so that's where the idea of data-driven decision making comes in. And so somebody else may have done that for you if you are not so much into data, but my expectation is that you will take the tools out of this class and redo that analysis for yourself and see, this is why I think this is the best choice for me. these are some of the scenarios, some of the factors that will help me decide why I want to do what I'm doing. Because without that, there is only opinions. There is no decision. Okay, the decision is only when it is built off of data. Okay, so yes, data-driven decision making, you bet. Okay, so I'm going to do a little quick thing with you guys because there is something else I want to discuss in the context of decision making. Okay, so we talked about statistics, and I said that statistics is not the entire piece of the puzzle when it comes to quants. Statistics is only one piece of the puzzle. However, I want to make a case as to why statistics is very important. Okay, so for each one of you, make sure that you have the syllabus open in front of you, be it in a digital form or be it if you have taken a print of it, I don't care, whichever way it is. But take the next 10 seconds to get the syllabus opened up. Okay, I shared the syllabus with you via email. The syllabus is available from your Blackboard. Just open up your syllabus. And now, either in your mind starts counting or in your using a pen or a pencil, all I'm asking you is to count the number of lowercase e or uppercase e. Don't differentiate between lowercase e or uppercase e as you start reading the syllabus. Okay, all I want you to do is count the number of lowercase e's or uppercase e's as you start reading from the first page of the syllabus. Your time starts now. And stop. So I'm just going to randomly ask somebody. Let's start with Sarah Alzarani. Sarah, how many did you count?
9.
9, very good. Nicholas Davis.
I did control find.
Ah, you did the smart thing. Okay, I didn't ask you to do that, but
Yeah.
that's one way of looking into it. So what was your number, by the way?
2,219.
Let's keep that in mind. Ryan Delworth?
I counted 15.
15. Justia?
I got 15 as well.
Fantastic. Matt Putman?
12.
12. So between 5 students, or 5 users in this case, for a process as mundane as counting the number of e's, be it lowercase or uppercase e's, we have 9, 12, 15, 17, 2000 something. And that is the reality of processes or the world that we live in. So this reality is also called variability. There is variability that is natural in data. Now, we might want to ask ourselves what led to that variability, and that's where the problem solving becomes. Okay, somebody took a head start into it, somebody waited, somebody was thinking through, should I consider the e's, the lowercase e's separately as opposed to uppercase e's, even if Dr. B said it, they're the same, because our minds think in different ways. And then there was somebody who said, hey, I'll just do a control find and let the analytics, the internal analytics do it for me. So everyone thinks in their different ways, and that's no different to any process from anything else that we see around us. You walk into a store and the person who is serving you will take different time to serve every other person, right? Because that depends on how much time you are spending talking to them. Some people are quick, some people talk forever. It can be a server issue. The server can be a new person working there versus somebody who is seasoned. And so there is a natural variability that exists in every single data set. And this goes back to our first slide where we talk about being able to try and manage something is only possible if we can measure it. And so if we want to manage variability, that is the best piece of the puzzle, right? My life would have been so much easier if each one of you got the exact same grade in this class. That's not going to happen. I'm telling you right away. Okay, there is natural variability in the process. My job is to try and ensure that I can bring that variability down to a bare minimum. That's when I know that a class is building on something together. They're learning something together in a similar way. At the end of the day, when a certain product is passing through an assembly line, the expectation is every time it takes a similar amount of time. It will be different, but as close as it gets, that builds efficiency in the system. It also helps you manage that data properly, because now you know exactly where the problems can be. So that is my first takeaway for why statistics is important. Statistics helps you in first measuring variability. So take a note of that. Statistics helps you in measuring variability so that now you can manage variability. So that is one of the most important reasons for statistics requirements in quants. The next one is something I want each one of you to take away, because we are so intrinsically connected to opinions, especially in the world of social media. Opinions are not informed decisions. Okay, opinions, everybody has one. Informed decisions come from data. And so the biggest difference between an opinion and an informed decision is the level of confidence you have in that decision. Okay. It is different saying that I think I'll pass the class versus saying that I'm 95% confident I'll pass this class. The former is an opinion, the latter is an informed decision. When you say you're 95% confident, then I'm sure you have done your homework. You have looked into students similar to you who have taken this class with similar backgrounds, with similar skill sets, and seen where they are with the class. And based off of that, you're making the decision as to where do I fall in that category. That allows you to be confident about your decision. So that's the second piece of the puzzle with statistics. Statistics allows you to make informed decisions, but with a certain level of confidence. Because without confidence, it's just a bunch of opinions. It doesn't really hold any truth or value. And this is extremely important, especially since over the last 3 years, we have been bombarded with the idea of fake news and fake reports and so on and so forth. It's important to understand what defines fake. The definition of fake should come primarily from the amount of confidence you can put behind a certain justification that you are trying to make to the rest of the world. As long as that confidence is bona fide, as long as the confidence is logical, it's not fake. It's fake only if there is no confidence in your judgment. And it's statistics that actually helps you offer confidence. That's where the idea of, so when I use the statement that I'm 95% confident that I'll pass this class, I can rephrase that statement by saying the likelihood of my passing this class is 95%. So when I use the term likelihood, that is a sane individual's term. The insane or the statistician's term is probability. Okay, so you're using the same exact term and saying there's a 95% probability that I'll pass this class. And that's where statistics comes in. It builds confidence around your decision. The need for continuous improvement. We have been talking about this from the previous slide itself. To be able to manage something, you need to measure it. And when you talk about management, it's about improving it. So continuous improvement happens both internally to a process or externally based off of consumer feedback. Okay, every single product that we use today are so heavily invested in consumers. The fact that each one of us have the power of the internet ensures that we all have an opinion, and in certain cases, the consumer feedback in terms of opinions matter. When a group of opinions point towards the same direction, then that can be converted into a fact based off a certain level of confidence that you put on the opinion. Okay, and so sometimes consumer feedback is used to better a product. If you're looking into a product in its life cycle, and especially multiple levels of products that are coming through the life cycle, one product is over, the next one comes in, why should I offer the next product? Unless it offers a cool set of features that the previous one does not. And so when I'm talking about a cool set of features that the previous one does not, who made me decide that those are the features that I'll be offering in this product? It's the consumer. That's where the feedback comes in. Okay, so it's a continuous improvement, both internally in processes as well as externally in customer feedback. And then last but not the least, and this is where I'll talk about the ethical aspect of managing statistics. By the time you're done with this class, you'll be quite dangerous with numbers. When I say dangerous, you have the option of telling data tell its story. You also have the option of telling data tell your story. And I'll be hopeful that you will not pursue the later path, because that is a path to destruction. Okay, so you can use statistics to an extent, and especially if you're not showing the entire picture, to tell lies. But this is where we have a dearth of individuals in today's world who can actually manage numbers properly. This is where this course can be an asset for you, not just for the curriculum, but for everything else that you do in your respective careers, because the truth is that we are rapidly entering a world where everything can be monitored and measured. But the big problem is going to be the ability of humans to use, analyze, and most importantly, make sense of data. So says Dr. Eric Brynjolfsson, who is the economist and director of the MIT Center for Global Logistics and Digital Business. This is what my initial couple of articles that I shared with you in the email also kind of points at. That's where the demand is, because there is a tremendous amount of data out there. And for my electrical engineer, who is that? Timothy? And Tim, I'm also an electrical engineer, so I can connect with you on that. One of the biggest takeaways in the last couple of decades is the way we have been able to utilize Moore's law to its absolute advantage of trying to make products smaller, work in the nano stage, and being able to save as much information as we can within a small piece of an equipment. I mean, today we all walk around with flash drives that can hold 64 gigabytes of information or data. That's tremendous. I came to this country 20 years back, and I still remember that in 2001, I bought my first, and don't laugh at me, please, but I'm just old. I bought my first 512 megabyte flash drive at Walmart for $35. And that is a reality. I wish I knew that I was going to teach at that point of time, and I would have saved the receipt to actually tell you that I'm not lying. But that's how far we have come in these 20 years. 512 megabytes. I mean, you guys probably are rolling your eyes and asking yourself, what is he talking about? But that is what has ensured that the data warehouses are saying, bring it on, as much data as you can. Let's store all of it. So there is enough data out there. The problem is the last piece of the puzzle, which is the ability of humans to actually use, analyze, and make sense of that data. That is lacking, and that will make the difference. So if you can take anything out of this class that allows you to make sense of data, that makes you extremely valuable, that makes you marketable, that makes you competitive. So while we are on that analytics mode, let's talk about some broad classifications of analytics, if you will. Okay, and this is what you may have read in trade journals, or if you are listening through TED Talks or stuff like that, you come across these terms all the time. But what the heck is the difference between them? Let's try and ensure that we create a solid footing of these as we move into your learning module 1. So very broadly, by methods and purpose, there are 3 parts to analytics. So one is what we define as descriptive analytics. Okay, so this is where you gather your data, you organize your data, you tabulate that. So this is where the idea of reporting comes in. And many of you touched on this in terms of what your expectations are from this class. So to be able to report a data in a simplest possible form. And that is an art in itself. Okay, and so that just tells you what the data is talking about. It does not analyze the data. Descriptive analytics does not tell you why the results happened the way they happened or what would happen in the future. It just tells you a story that the data is trying to tell. And that is oftentimes the starting point of the puzzle. That is oftentimes where you visualize and try to understand what is the story that the data is trying to tell. So I take an exam for these 20 students, and I have about 50-50 breakdown of males and females in this class, let's say. And so when I do an exam, if it turns out that for this data set, the women in the class fare better than the men. And if I plot that data, the data should be telling me that story. That doesn't necessarily mean that women are better than men. It just means that this specific data hints at that. It's a different story as to infer saying women are better than men in analyzing data. The current data set of 20 students analyzed from gleaned from or gathered from Dr. B's class suggests that women may have a better understanding of data management than men. I can say that. And that's where I can stop with descriptive analytics. When it comes to predictive analytics, that's where I'm looking into associations and relationships. I'm trying to see how the different parts connect. This is where I'm trying to predict the likelihood of a phenomenon. Okay, this is where I'm trying to say with a certain level of confidence if women actually are better with analytics than men. And that level of confidence comes from statistical techniques. So that's where the predictive piece comes in. So causal modeling, a cause-effect analysis. That's what is done in regression, and time series regression is one piece of the puzzle. Time series regression is when you are doing causal modeling with time as your x-axis. In other words, you're looking into how a stock price moves over time, or how consumers' behavior shift over time. Okay, so all of that is also causal modeling, only around time as your x-axis. And of course, there is forecasting, where you are predicting, or at least trying to predict the future. So all of that is part of a broader domain of analytics known as predictive analytics. And I'm also talking about these things because eventually at the end of this class, you should be able to redesign your resume or CV based off of these keywords, because that's what oftentimes the industry is looking for. And as I have said before, I am heavily connected with the industry. That's one of my strengths. That's what I do as director of my center. And I'm more than willing to work with each and every one of you to work on your resume to ensure that it is industry ready. And especially to ensure that it justifies your learning from this class and it's showcased properly in your resume. Okay. The third piece of the puzzle is what we define as prescriptive analytics. Okay, so this is where the suggested course of action is where you report back to the management. Because when you are organizing, tabulating, and gathering data and reporting out how the data is seeming that it is behaving, your management group is looking at that and says, yes, but so what? The so what part is what the prescriptive analytics tell you. So that's where you do experimental design, as an example, a pre-study and a post-study. So when people are testing a drug from AstraZeneca as a possible vaccine, they're also using placebos to another group of people, okay, who are thinking that they're using the drug, but they are not. And you're trying to see changes between how the drug actually interacts with the human body based off of those two. So those changes then can be reported. You can do scenario analysis. You can do decision trees. You can do optimization. You have multiple possible scenarios to persuade. Which one scenario should you choose? That's where the idea of optimization comes in. The best scenario, the path of lowest cost, the path of highest profit, the path of lowest time to get my customers or my products through my system. Okay, so that's where the optimization piece comes in. So that becomes a prescription to the management, and that's what prescriptive analytics is about. So from an industry need perspective, you will often see this, and this is why these are skill sets that need to go in your resume if you want to see a career in analytics. Because from a broad industrial perspective, the need from an analytics professional is fivefold. Okay, you are expected to understand statistical analysis. You're expected to understand forecasting, and there is a subtle difference between forecasting and statistical analysis, even though you use similar techniques for both forecasting and statistics. In forecasting, you extrapolate. In statistics, you interpolate. Okay, and we'll talk about those as we discuss regression later on in this class. Then, of course, there is optimization, which is finding the best possible alternative. Then there is simulation, which is you don't have enough data with you. How do you use techniques or tactics to simulate the entire process? So for those of you who are into airlines industry and aircrafts, Boeing is a great example. So Boeing's 787, which they dub as their Dreamliner, was completely simulated from parts to takeoff before even the first dollar was spent. And that is how they ensured that all of their processes are in place and they are working exactly the way they are supposed to work before they go out to find the parts from global suppliers and so on and so forth. So that's the importance of simulation. And last but not the least, you have what we define as big data management. So that's where data mining and specifically big data, and the second article that I asked you to read, looking at the 3 V's of big data, kind of looks into that domain. And that would be a very interesting opportunity for you. And something like Tableau or even R allows you to visualize big data. They can take in as much data as you want and still make meaning out of that data. So it's about telling the story from big data is what big data management is about. So very broadly, I would want to talk about some of the analytics applications in business and how analytics applies to different business segments. So if you look into marketing as an example, okay, pricing. Okay, pricing is one of the biggest areas within marketing where analytics is applied. How do you price a product? We actually have a course offered by Dr. Bhowmik here in the College of Business called Product Pricing and Strategy that deals with a lot of the analytics that go behind pricing. There's a lot of economics naturally that you can feel that comes into the scheme of things when it comes to pricing. Store and branch location, and a lot of that has to go along with the demographics, understanding the demographics within which you're operating and designing branches and store times and what is the offering within those stores based off of those demographics. Promotion targeting, which parts of a demographic do you target for a certain level of promotion? Search engine optimization. Okay, so if I am looking by, I'm trying to find I'm interested in supply chain management, okay, and I have put into Google supply chain education, comma, Midwest, comma, Indiana, comma. Okay, so Google is taking all of those into consideration and running its optimization. And so then that becomes a close call for you to take a look at, is Indiana State Supply Chain Program mentioned? If it is not mentioned, then the way Indiana State is marketing the program is faulty, because that's where certain keywords that users are looking for are not translating in what they're actually looking for. Okay, so that's where search engine optimization comes to rescue. And this is what digital marketing is essentially about. So we are as digital as it gets thanks to this pandemic, and we are probably setting the stone for a full online MBA going forward. And I don't see any reason why we can't offer that. Social media analytics, and there is enough that has been said about it. The top companies have been summoned to Washington to talk about privacy issues in terms of the kind of data that they gather and how are those analytics taken into consideration. It is a huge, huge area, and all of that forms part of the broader context of marketing. Analytics in operations, supply chain, logistics. This is where you're looking into inventory optimization. How do you go about finding the right amount of products to order every time you place an order? Or what is the right size of customers I want to serve from a service point of view? Okay, so when I talk about warehouse location and vehicle routing, okay, so this is where Walmart is a great example, because Walmart builds their business around distribution centers. So distribution center is essentially their hub of the business, and warehouse locations and super centers are essentially their spokes that allow to connect with those hubs. And so arranging where those warehouses will be located so that you can minimize the movement of vehicles is the key. And this is where optimization also comes in. This is where a lot of other analytical techniques like centroids and all of those jazz come in when it comes to warehouse locations. Vehicle routing, that's also an interesting area. How do you route a truck that is carrying products or parts for multiple destinations? Again, the idea is to reduce the overall time the truck travels, because the less the truck travels, the less fuel is spent. Okay, the less the fuel cost is, the less wear and tear on the truck, the less wear and tear on the truck driver. And if you want to be sustainable and bring in the green piece of the puzzle, you also want to understand how much of carbon footprint are you leaving behind. So all of that can be analytically captured in the vehicle routing problem. Supply planning, it is very similar to demand planning. So how much do you produce? How do you go about the production? How do you forecast what's the next demand is? And based off of that, how do you justify the production process? Transportation systems design. So this is in terms of, if I am managing a business, let's say a Walmart is, Supercenter is getting materials from 3 different warehouses. So how do you decide the distribution and balancing of those products or parts through all of those warehouses? Quality control and lean. So how do you manage quality? How do you manage lean? If you have come across the term called Six Sigma, it is a widely approved term in the context of lean. We actually offer a course in Six Sigma, and students can actually earn their green belt in Six Sigma. I'll give you a kicker. Given that we just discussed variability, Sigma is a measure of variability. So at the end of the day, all you're trying to do is reduce Sigma, or reduce variability in your process. And that connects back to the discussion that we had about improving for the sake of managing, because that's what we are after. If we can't capture variability, which is what statistics does for us, if we can't capture variability, how do we know how to improve on variability? And that's the importance of statistics within analytics. And you will study a lot of these in your MBA 623, which hopefully you should take in spring. And this is just a suggestion, because all of you are taking MBA 612 with me in fall. By December 8th, you will get a lot of knowledge gathered. By March, a lot of that will go away if you don't apply them. So my suggestion is to work with Ashley and ensure that you take MBA 623 as a follow-up class to this class the following spring. That way you will be still current, you will be still fresh with the learning here, and you'll apply a lot of these things into your operations class. Analytics in finance. So this is where your financial performance drivers come in, performance scorecards. How do you design those scorecards? How do you prioritize the elements within the scorecards? Investment portfolio optimization, finding the optimal portfolio that meets your needs in multiple directions, be it in terms of age, be it in terms of how risk averse you are, be it in terms of your current salary, and so on and so forth. Forecasting, and this is very much embedded into most of finance. And when I say finance, I'm also mentioning financial planning, insurance. They're all part of the broader bucket called finance. And of course, risk management. That is a huge area, not just within finance, but also within supply chains. And I'm a certified risk manager by trade. So a lot of risk management has to do with managing variability. And so there's a lot of statistics that go also into risk management. Last but not the least, into human resources. Okay, and you would want to think that this is very behavioral. How do you go about putting an analytic spin to it? And this is where the tremendous amount of work has been done. For those of my students who talked about having a background in psychology, this is one of the most interesting areas. I have myself done some research on job fit. I'll talk about that in just a second. But understanding long-term employees is a psychological skill. Understanding that an employee will stick to you. Understanding that an employee will actually grow in a certain company. And that's where understanding job fit is critical. And so job fit analytics go into seeing where the employee's background is, where the employee's thought processes are, where the employee's mindset is, culturally where they come from, and connecting that to the company culture, and trying to see if there is a fit. There are algorithms in place that ensure a certain percent defines a fit, and anything below that certain percent is not a fit. And that will then in turn allow you to make a decision on which ones to hire for the long term, which are more likely to leave. And then you have compensation modeling, which is how do you design compensation packages based off of an employee's skill sets? How do you design training rationalization? And that applies even to Indiana State. So when Indiana State marketing is thinking about marketing a certain program, they are going back to a basic rationalization that says, why should I market you? What makes your program successful? So training rationalization is no different. If you offer a training program to the entire company, that is an extremely cost effective measure, cost involving measure, sorry. And that happens. So I think, who was I talking to? Was it Amy who was talking about SAP? And so when SAP is implemented into a company, it becomes a company-wide implementation. And so everybody in the company at different levels have to go through SAP training. That's the different scenario versus when you rationalize training based off of certain sectors within the company. So even when you talk about SAP, when SAP is brought in, it's typically brought in with the lowest hanging fruit. And the lowest hanging fruit is essentially the easiest factory that is running at its optimum level. And so they build on that, and from there they look into how they can spread that concept into the rest of the company. And so there's a tremendous application of analytics in these areas. Now, the art of problem solving, I have added a couple of slides here, primarily to kind of get you started with your learning module 1. So the first one is addressing a problem. There are 3 broad criteria here. One is formulating the problem, followed by solving that problem, where you data collect, you model the problem, you analyze it, and then very important is communication. And I talk about these in much more details in the learning module 1, okay? And the next part is to part today with a very broader definition of statistics, which is an area of science that extracts information from numeric data. And you know, this is what I was discussing with Nathan, I believe, that at the end of the day, statistics is a science that converts data into information and helps you make inferences about the source from which the data is obtained. And a lot more of this is discussed in the learning modules, especially in video 1.2.